Hello students, how are you doing? You fine? Okay, so we have been discussing the entrance module of the chapter rotational motion. Now, let us start with the next entrance module of the chapter rotational motion. In this module, we are going to discuss multiple choice questions based on, yes, the concept of angular momentum and its conservation. Students, we have already seen very important MCQ based on this concept. So, let us see what's there in this particular module. Are you geared up? Okay, so let me start the module. First, let us take a look at the question. Oh yes, it's a very small question. Okay. If radius of Earth suddenly expands by n times its present value without change in its mass, then the length of the day is, okay, what are the options? Option A is 24 hour, option B is 24 upon n square hour, option C is 24 n square hour, and option D is 24 n hour. Alright. So students, what is the procedure? Yes, first we are going to identify the problem, second we are going to set it up, then third we can execute, and fourth we can evaluate. Okay, so can we start the solution? Alright. First, what is the first step? Yes, first step is identification. So students, what is given in this question? Yes, very good. If the radius of the Earth suddenly expands by n times its present value. So what I'm going to do here is, I am going to assume R1 as the initial radius. Now what is happening? Radius is expanding n times the present value. So I can write R2 is n times R1. Is this correct? Yes. Now, what else is given? See there's a very important statement. Without change in its mass. So, mass is going to be the same. Alright. Anything else you can justify? Yes, we know one thing. The time period of rotation of the Earth is nothing but 24 hours. So I can write T1 is 24 hours. Alright. Now why I am doing this? See that in the question. What is asked? The length of the day is asked. So that is why I am taking the initial time. Initial time period of rotation is 24 hours. Asking the length of the day. So that means if the radius changes, keeping mass same, what will be the new length of the day? That means they're asking what is T2. Alright. Now we have T1, we have M, and we have R2. So how to find out T2? Yes, which formula? Title of this module. Very good. We can use law of conservation of angular momentum. The net external torque acting on Earth is 0. So angular momentum of the Earth is conserved. So we can write I1 omega 1 equals to I2 omega 2. Initial angular momentum is equal to final angular momentum. Alright. Now students, we don't have omega, but we know some formulas for omega. T is there. Which formula? Yes, circular motion. Very good. We know that omega is 2 pi upon T. If I substitute it over there, I will get I1 into 2 pi upon T1 equals to I2 into 2 pi upon T2. Is that clear? Now, what is I? I is moment of inertia. That's all right. What formula will you use here for I? There are many formulas we have seen. Moment of inertia. Yes, Earth is a sphere and Earth is solid sphere. Earth is rotating about an axis passing through its diameter. So we know the moment of inertia of a sphere about an axis passing through its diameter is 2 by 5 mr square. So I can substitute it here. Yes or no? Fine. Now let us go on to the calculation part. Now students, first what I'm going to do is, you see that formula? Alright. Now, we know that I is 2 by 5 mr square. So what will happen? I1 will be 2 by 5 m1 r1 square. So we can write I1 is 2 by 5 m1, which is m, r1 square into 2 pi upon t1. Now, what about I2? Now I2 will be, see there, R2 is nr1 and m is same. So I2 will become 2 by 5 m, instead of r2 square, you will write n square r1 square into 2 pi upon t2. Did you understand? Because R2 is nr1. Alright, now students, it is very simple. What we can do here, now we can cancel out certain terms. 2 by 5 gets cancelled, m also gets cancelled, yes, r1 square also gets cancelled, then 2 pi also gets cancelled. So what do you get students? You will get T2 is n square T1. Now, we know what is T1, yes or no? If you know T1, you can find out T2. Now see there, T1, it's already given. T1 is 24 hours, so if I substitute it over there, I will get T2 is 24 n square r. Is that clear? See, remember students here, R2 is nr1, mass is same. So now, let me bring back the question and see which is the correct option. There you go. Which is the correct option? Yes. Option C is the correct one. So students, It's a very important question. Again, I have used conservation of angular momentum, but remember, here mass was same, only the radius changed, and the time period has also changed. Is that clear? So I'll catch you up in the next module. I'll just disappear and appear. So until then, keep working, don't give up. Rise and shine.